Hello everyone, let's look at Leetcode question 605, can place flowers. So in this question, you are given a long flower bed in which some of the plots are planted and some are not. This is the input array list flower bed. However, flowers cannot be planted in adjacent plots. Given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and an integer n, that's the second input value, return true if n flowers can be planted in the flower bed without violating the non-adjacent flowers rule and false otherwise. So before looking at the examples, let's look at the constraints. So the flower bed.length array will be somewhere between 1 and 20,000 units, and the values at flower bed I is either 0 or 1. As we mentioned, 0 is not planted and 1 is it is planted. So there are no two adjacent flowers in the flower bed. That's the whole point of the question. And the flower bed length will be between 0 and flower bed.length. So let's look at the examples. Okay, so here we have the first example and the code. Let's run really quickly through the code and see what's happening here. So what we first do is use the enumerate function to loop through all the values of the flower bed and provide an index for every value of the flower in the list array. So if the value at index I of flower bed is 0, and then the previous value is also 0, and the value after it is also 0, this means that we can place and plant our flower bed into the current index. After this is done, we can subtract 1 from n, which is the number of flower beds that we can need to plant. If this value is 0 or less than 0, that means all of the flower beds have been planted and we can return true. Otherwise, this is not the case and we just return false. Alright, so we have this first example, flower bed equals 1, 0, 0, 0, 1, and n equals 1. So we first loop through the enumerate flower bed and we check the conditions. So I is currently at 0 and flower equals 1. If flower is equal to 0 and, alright, we can just simply ignore all of this conditional statement because the first flower is valued at 1. So we loop to the next index and it becomes 0. Now we check once more. Is flower equal to 0? Yes. Alright, then are its adjacent values also equal to 0? No, because the previous value has 1 as a flower and this makes it false, so we cannot add a flower at this index. Next, we are at now index 2. And this, let's check if we can plant it. If flower equals 0, yes, and the flower at previous index is 0 also, and the one after it, we can plant it. Okay, so we do this same thing. We plant the flower bed, so flower bed at index 2 becomes 1. We subtract 1, n becomes 0. So if n is less than or equal to 0, we return true. So we simply return true in this first example, as we have planted the single flower bed needed in non-adjacent flower beds. Okay, here's the next example. Here in this case, the flower bed is 1, 0, 0, 0, 1, same as the previous example, except we want to plant 2 flower beds. Is this possible? Let's run through the code. So we loop through every single flower, enumerate indices. So I is currently at 0. If flower equals 0, not the case. Next flower is 0. If flower is equal to 0 and the adjacent values are also 0, not true. Next value. So we go then to this value. And it is possible, because just as we've previously seen that this is true, we can plant our flower bed here as non-adjacent values are not planted. So we put our 1 there and it becomes 1, 0, 1, 0, 1, and n becomes 1 now. So we move to the next one, it's 0. Can we plant one here? No, we can't. We go to the next one again, we can't plant one here, so we return false because n never equaled 0 or less. Alright, for this final example, I have another one that I made up, so 0, 0, 1, 0, 1, 0, 0, and we want to plant, let's say, 2, n equals 2. Can we plant 2 flower beds here? Let's say n equals 2 here. Well, let's look through the code. For I in flower, if enumerate flower bed, okay. First value at index 0 is equal to 0. Okay, so far so good. If I equals 0, yes, and I is equal to length of flower minus 1, or flower bed at I plus 1 is equal to 0, this is true, then we plant our flower at that index. So flower bed at I is equal to 1. This is 2, so this becomes 1, and then we loop to the next one. We can see this has become 1, and adjacent values are 1, so we can't plant here. 1 is already planted at, cannot plant here. 0 is not planted, but the adjacent values are already planted. Then we finally arrive at the last value. Okay, let's loop through it. The last value is at index 6. Okay, if flower is equal to 0, this is true. And if I is equal to 0, no. Or flower bed at I minus 1 is equal to 0, true. That's this value here. And I equals length of flower bed minus 1. This is actually true, because the length of flower bed is 6, minus 1 is 5. That's the index, this current index, which is 0. This satisfies the conditions. We don't care about flower bed I plus 1 since there is no other adjacent value after it. This is the last flower bed in the list of numbers, so we can simply subtract 1 once more from n and become 0, and we return true. Okay, let's look at the solution, see if it works. Okay, let's run the solution, and it works. What is the time complexity? So the time complexity is O of n, where n is the length of the flower bed. This is because we iterate through each element in the flower bed once. And the space complexity is O of 1, because we are not using any additional data structures that will grow with the input size. That's it for this question. Thank you so much for watching.